Okay, so again, I wanted to show you how we could utilize Microsoft Excel for, well, before I showed you for one variable stats, now I'll show you for two variable stats to do all the number crunching. Okay, there are other videos that show you how you can quickly do these calculations, and I will post those as well in the CPT section under a whole section of Excel videos or Excel tutorials. But really, I want to be able to show you also how to utilize Excel so you could do your long number crunching. The number crunching that you would have to do by hand that I expect you to do, as the explanation is for as far as how to do an R value, how to do an A value, and how to do a B value. Okay? So, anyway, what we really need to do, if you look at the formula for your correlation coefficient R, and you look at the formula for the slope and the y-intercept of your regression, your linear regression, you need to have all of these characters. You need to have x, y, x times y, x squared, y squared, and of course you need n. Okay, and those are all the different values and the number of data points that you have. Now, what we need is not just the values, but we need the summations of them. In fact, all the formulas have to do with the summation of x, the summation of y, the summation of xy, the summation of x squared, the summation of y squared. Those are all key players. There's also a mean x and a mean y when we're figuring out what the b value is. And we can do those as well using this, okay? Because we can sum very, very quickly very large amounts of numbers. That's the beauty of Excel. So what I'm going to do is create a little formula here. The formula I'm going to create is, I want to be able to take x, the time, and y, the price or the stock price, the closing value of the stock, and I want to be able to figure out x times y. Okay, so I can do the summation of x, y. So I create my own little formula for this particular calculation, and I say I want it to be this x value, 1258, times, which is a star, my y value, which is 4562. And of course I know I can do that with a calculator, but it's a huge number. And I want to do it 1,258 times. This is where you need Excel in order to do it. So again, you do that formula once here. You want it to slide down, so this spot right here will be 1257 times 4612. Okay, so what I do is I take my fat plus, I go to a skinny plus, and I drag the formula all the way down to 1258, or actually 1260, because we started at a bit different of a value. Anyway, and that will replicate that multiplication process. Okay, again, not only do I want to have the sum of x, y, which I'll show you how to sum up in a second, but I wanted to do just x times y. But here I also want to have x squared. Okay, so x, of course, is my time. So I go, in this spot here, I go equals. Okay, I guess I could make it a little bigger. Well, I'll do it afterwards. Equals, and I take my x value, okay, and I raise it to the power of 2, hat 2. Or you could just go x times x if you wanted to. All right, depending on how you're feeling. And it's a huge number. Huge, ridiculous. I don't want to have to do it all the time, so again, I replicate the formula. I go from fat plus to skinny plus, and I drag it down. Can go all the way down 1,200 and I think it was 59, or 1,260, depending on what I started things at. And of course, we get down all the way down to 1, because 1 squared is 1, and 2 squared is 4, and 3 squared is 9. But all these rest of the values are going to be huge. Again, I go all the way up because I want to do y squared. This is going to be the square of the stock price. That's my y. Okay, that's my dependent variable. It depends on the time. As time goes by, my stock price changes, so my price depends on my time. Anyway, again, the formula for it equals, and I want to go y squared. So I click on y, and I go hat 2. Or I could just go y times y. And that's going to be 45.62 times 45.62, which is about 2,000 a bit. Okay, and then again, fat plus to skinny plus, replicate all the way down till we get to the bottom of my data set. Okay, now we've got all of these different calculations done. Now we're going to use our sums for all these. And if you notice, I've already got sum written over here. I want to sum up x. The reason why I want to sum up x is because not only do I need to use it for my calculations, for my R value, for my A value, for my B value, for my R value, my Pearson correlation coefficient, for my A value, my slope of my linear regression, and for my B value, my y-intercept of my linear regression. But I'm also going to need to figure out the average value, again, in the calculation for B. Anyway, so for my sum, I use the sum function. Okay, I go fx, I look up sum. It's probably already in here anyway. I click on it, or you can type it in sum and search for it. Insert the function. It's going to guess already that it wants to be N2 all the way to 1259, and that is what we're doing. Again, I'm going to copy that just in case. Well, that won't be as useful to me here. But anyway, it's a good idea to copy it if you're going to be reusing it a lot. I'm not going to be reusing it a lot here. And I want to add all those guys up. Huge sum. Okay? Then what I want to do is I want to take that and I want to do the sum for all of these guys too. So I drag it all the way across. Now, the reason why I do that is I do all of these sums because for all my formulas that I want, let me get rid of that function. For all the formulas, for the R value, for the A value, and the B value, I'm going to need the sum of x, the sum of y, the sum of xy, the sum of x squared, the sum of y squared. And I have all that all the way down here at the bottom in my sum column. For my average, I could just go ahead and take this value and divide it by 1258. So I'm going to do that now. I take this and divide it by 1258, my sample size. And for my average y value, again, I take this number, my sum, and I divide by 1258, okay, to get my mean. Mean x value, mean y value, okay? Quite simple, all right? And then, of course, all of these values, sorry, here, 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 and here, the values I'm going to use for my r. Okay, now I'm going to do the R value in here. You don't have to do this. You can plug it in. You can go ahead and calculate it yourself. Use your calculator if you want to. Heck, you could even go ahead and do a scatter plot and trust that the value will be right for R. Okay, as long as it'll give you an R squared value, you could square root it and work your way backwards if you want to. But I'm going to go ahead and input my own formula. If you remember, the numerator for your R value is the n times the summation of xy. Okay, minus the summation of x times the summation of y. Okay, so I'm going to go ahead and do this. I'm going to go n. I'm just going to put in the number 1258, right? And then star for multiplied by. Okay, and I want the summation of xy. This one was the summation of xy. Okay, and that's going to be that first part. Then I'm going to subtract my summation of x times my summation of y. Now it's going to follow the order of operations. So it's going to do multiply these two guys together and then multiply these two guys together and then subtract them later on. So that's what the numerator of my R value is going to be. And this is going to be a decreasing relationship. As time goes by, the stock price has been going down on average. I don't know if that's the case. It's a 45.68 in day one. And then in the end, it's a 45.62. Maybe it's a very, 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 very subtle decrease. Either way, it's going to be a negative correlation. Okay, and so I've got that calculation for my numerator. Now for my denominator, okay, I've broken it up into two brackets. If you remember, it's a square root of, very huge number. It's going to be a square bracket, okay, and it's going to be n times the summation of x squared minus the summation of x squared, okay, and that's one factor. Then there's another square bracket, which is n times the summation of y squared minus the summation of y squared. Okay, that's the other factor. So I'm going to do those two factors separately. So I go equals, and I'm going to go 1258 star again times. Okay, and I'm going to do the summation of x squared. This is x squared minus the summation of x, this guy, squared. So I go hat 2. Press enter, and I get a value. Okay, it's 2.08 times 10 to the 11. That's scientific notation. Okay, it's a big value. All right, and then for this one again, I will go the same scenario. This is the other factor, but again, it's for y. So we'll go 1258 times my n times my sum of y squared. That's this number. Okay, minus the summation of y, which is this number, squared. So hat 2. And I press enter, and that's going to be my other factor. In this case, it's not going to be too huge of a number. It's only going to be about 8.8 million. Okay? Now, for my denominator, okay, I still have to square root it. So there's a little bit going on here. So now when I go back, so I'm just going to input this number here. So equals, I'm going to input that number here because I've already done the work. Okay, that's my numerator. For my denominator, I'm going to have to do these two guys multiplied together and then square root it. So there's still a little bit more for me to do. So I'm going to go equals, I'm going to bracket it, and I'm going to go this star multiplied by this, that value, the two factors, close my bracket, raise it to the hat 0.5. That's going to be to the power of 0.5. Again, you can do this with your calculator if you want to. Okay, and then I go equals, and I go my numerator divided by my denominator, and I get my R value, which is negative 0.0486. Not a very strong negative correlation. Okay? Now you can go ahead and if you want to, you can go ahead and do a scatter plot to test to see if this is right and get yourself an R squared value. All you got to do is take this data, drag it. Let me drag it all the way down. It's going to take a bit of time. And they're side by side set up as X and Y. So it's pretty easy for me to do this work. I've set it up so that it works out nicely for me. Okay? And then I go ahead and I do a scatter plot. So I go insert and then my little scatter plot. Boom. Okay, and as you can see, it's not really a great correlation. It kind of meanders, right? And you can't even see individual data values because there's 1,200 of them. There's a lot, okay? Again, to add my chart element, okay, I want to add my trend line, and I want to go down to linear, okay? But I want to do more trend line options, so I have this drop-down menu that's here. Linear, but don't forget I need my, well, the equation would be nice, and my R squared value. And I'm going to check out that R squared value and then square root it and see if that's appropriate, okay? All right, so I'm going to close that. I haven't figured out my equation of best fit. Maybe I'll do that in another video. I don't want to get this, oops. I don't want to get this to be too long. Oh, I don't know where I put that graph now. It was 0.0024. Oh, here it is here. Good. Okay. So I have it in a convenient spot for me here. Okay. So 0.0024. So if I go ahead over here just for fun and I go equals 0.0024, knowing that I don't have all my decimal places in there, and I raise it to the power of hat 0.5, because remember it's an R squared value. For me to get my R value, I have to square root it. And I get 0.04899. And here I got 0.04863. It's very difficult for you to see that it's a negative. When you square root R squared, it can be positive or negative, right? But you can see here that my slope is just slightly negative. So again, this is a way in which you could figure out an R value. And then later on, if you wanted to, you've got all of the different numbers. You've got X, sum of X, sum of Y, sum of XY, sum of X squared. That would give you your A value, right? And then you've got your mean Y value minus your slope, your A value, times your mean X value, okay? And that would help you figure out what your Y-intercept is. And hopefully you would get pretty darn close to this very, very, very shallow slope and a Y-intercept of 44 and a bit. Not a very good line of best fit, but you know, this is a process, right? This is us going through and analyzing these statistics to see if we can see patterns and differences. Who knows? Maybe this is a fairly stable stock, right? So it doesn't really change that much in price. Okay, so as a result, over a 5-year period, it probably didn't go up or down. They call them blue chip stocks because they're pretty good investments, pretty stable. Okay, and hopefully they would earn you some dividends and things like that as a part of an income profile. But anyway, that's neither here nor there. That's a little bit of the calculations that you can do. Okay, hopefully this video helps you out. The rest of the calculations I've already done in videos in a single variable stats and 2 variable stats videos. So those are all ones you would want to do as well. Hopefully that works for you.